Let's go over the code of the UART then on the STM32F4. Let's see the pooling method, where you have your main function. You're going to configure or parameterize the UART, and then during the while one you're going to send and receive data. Just a heads up that the UART code to receive and send is blocking, meaning you cannot run other code while you are waiting to receive or send information. This is the main function, so we initialize the microcontroller, the LED, the UART, and then we put some strings over the UART. And inside of my loop, I'm going to wait for a character, and then if that character is a capital H, I turn on an LED. If it's a capital L, I will turn off. So notice that these two functions here are blocking, and we'll see it in a minute why. Inside of the UART configuration, what we're going to do is to enable the clock of the GPIO-B, because I'm going to use UART 1, which uses the GPIO pin 6 and 7 on the B. And then I enable the clock for the UART. Then I parameterize the pins as alternated function. And then later on, I'm going to assign them to the UART pins, to the TX and RX pins. After that, you initialize the UART structure, you define your baud rate. In this case, I'm putting 9600, no hardware flow control. I'm setting up the mode to receive and transmit, no parity bits, 1 bit for stop bit, and the message, the data size is 8 bits. Enable the UART, and now to send and receive. So we are putting a string, it's a pointer to a string, and then while it's not a null like the end of the string, I'm putting that memory, the contents of that memory position, and I shift to the next one, so I'm pointing to the next one. Call put char, and I'm sending that character over the UART. But before, it's waiting until the data register is empty, and this is what it makes it blocking, is that if the UART is not ready, your code is going to stay here until things are done. Same thing for getting a character. You're going to wait in this while loop until the UART tells you that it's ready, that it received data, and then returns that data. So this is blocking actions. So let's see that in action on the video now. Let's see the UART in action. I have here the UART connected to the STM32F4 discovery board, and I have the RX and TX connected to your PB6 and PB7. So if you go up on the code, you will see that PB6 is going to be your TX. So I connect the TX to the RX of your UART, and then I connect PB7, which is the receiver, to the transmitter of your UART module. Second step that you need to do is you connect the serial device to your computer, but now you need to know which COM port is being used on your computer. For that, you go to your computer properties and your device manager, and under your device manager, under the ports COM, if you expand that, you'll see here that I'm using COM24. Alright, so once that is done, there are different softwares that you can use to interface with the UART. I'm going to use PuTTY, and I'm going to use a serial port here. So it's the serial port 24. This is my baud rate. I don't need to do anything else. I press open, and now it is connected to my UART. Going to my code, I'm going to deploy the code. The first thing that the code is going to do is to actually print hello world, and then if I press the H, turn on the LED, or the L will turn off. All right, let's deploy the code. All right, ready, and already has hello world here. And now if I press H, you'll see the LED turn on and off, on, off, on, off, on. Another letter doesn't do anything. You even see the LED here blinking, saying that it's receiving information. And turn it off, capital L. And that's pretty much how it works. A way to go around those blocking methods, it's using an interrupt method. For the interrupt method, we're going to make the receiving of the data non-blocking. So sending, it's still blocking, but receiving is non-blocking. For that to happen, we are going to have an interrupt routine associated with the receiving of the data of the UART, and we're going to use data as a volatile to communicate between your handler and your while in your main loop. So the code is pretty much the same. The only difference is that we don't need to do this get char now on the while one. We're going to do this inside of the interrupt routine. So this function is still a blocking function. Configuration of the UART, same thing over here. Initializing, nothing changes. And at the end of that, I'm just going to enable the ADC interrupt and make sure that I have access to the handler of the interrupt routine for the UART. To send the data, I'm going to use the put char and the put string. They are still blocking functions. And to receive now, instead of having the get char function, I'm going to put that code inside of your handler and using the volatile variable to communicate with the while one. So let's see this in action. Now let's test with the interrupt routine. So here I have the handler getting the char, and the behavior is pretty much the same. It will print UART 1 on and then turn on and off the LED. The only difference is that now I have a non-blocking function to receive the characters. So I'm going to compile, deploy the code. And let's see, run putty. All right, let's run it. Connect to COM24 and press play, and here you go, UART 1 on. And now I can press any letters. It doesn't do anything, it just receives over here information. But if I press L, in this case I have the this small H and the small L. So if I press the L, turning on and off by pressing H, L, H, L. So you pretty much see the UART working. You cannot see the impact of using this non-blocking function on this simple exercise, but as you start complicating your code, you will appreciate these non-blocking functions a little bit more.